Hey everybody, welcome to I guess this is week 10. So SuperCollider, and we are going to talk about the Open Sound Control Protocol today, or just OSC for short. Morning, Jumbo. How's everybody else doing? So OSC, or Open Sound Control, is a communication protocol that was developed, I believe, in the early 2000s. And it's meant to be a sort of general purpose means of getting computers and network devices and software and hardware and things to talk to each other. And hey, Scaldwell. Hey, Rianto. So for a bit of morning, B Hanks, a bit of light reading, you can go to opensoundcontrol.org, which is kind of just a website that details the specifications of the protocol. A very sort of casual way I like to think of it is kind of like MIDI for the modern era. So MIDI, which was released in the 80s, had very much the same purpose as OSC, which is to get devices, originally musical devices, but more general purpose than that, just devices to talk to each other. But OSC has a number of advantages over MIDI. MIDI has a predetermined family of messages, note on, note off, velocity, control, program change, etc. OSC is completely flexible, and you can define your own message categories and addresses and things like that, and you can make them human readable. OSC is not channel limited. There's a very, very high amount of precision. OSC messages are sent with I think a 64-bit float timestamp, so they're very, very precise, whereas MIDI clock messages are just sort of around the order of a millisecond or so. So it's a lot of improvements over MIDI. Also, the OSC protocol does not specify a hardware component, whereas MIDI originally did with the 5-pin DIN connector. But OSC is really more meant to piggyback off of modern networking protocols like UDP and TCP and things like that. Right, so let's see where to begin. So yeah, we're gonna start with an app called Touch OSC, and I emailed everyone taking my class, and hopefully you've got that on your phones or whatever. And I have got my iPad here, and I'm gonna see. This should be. Let's see. I might have to restart this. Oh no. Okay. Looks like things are working here. All right. So Touch OSC, which I've got here, is an iOS and Android app which allows you to sort of create and use a multi-touch interface to send OSC to a receiving network device. So let's just take a look at Touch OSC. So you might, if you open Touch OSC for the first time, you might find yourself in some sort of okay, I've got to allow network communication here. Okay, you might find yourself in one of these just interfaces or something like that. So you can hit there's a little it's a little white circle button up in the upper right corner, and that'll take you out of the interface view and into sort of the main setup page. So in the middle section here, we have layout, so we can pick layout. There's a bunch of predetermined layouts. So let's look at simple. And we've selected simple. Now we can hit done in the upper right corner. And this is this particular interface. It's got a couple of tabs on the left side here. This one, I guess maybe you're supposed to have this in a vertical layout, which is why the tabs are on the left here. But we have a sort of two-dimensional slider. We've got a couple of toggle buttons on this page. This page, we've got a bunch of momentary push buttons, so they're on when you're holding them, and they're off otherwise. So we're gonna design our own Touch OSC interface, and some OSC mobile apps lets you design and edit in the app, but Touch OSC doesn't. So to do that, you need to download and install the Touch OSC editor, which hopefully some of you have done ahead of time. So I'm going to open up the Touch OSC editor. Here it is. Right, so this is basically a desktop client for designing your own Touch OSC interfaces. So you can select whatever you like here. I'm gonna pick iPad. I'm gonna make this a horizontal layout and adjust the zoom a little bit. And we start with a single tab and a blank slate. And to put buttons and sliders and things on the canvas, you can control click or right click, and this menu pops up. And you've got some options here. So we'll make a toggle button, I guess. You can change the size of things. You can also, I think, change the size on the right here. If you want to change the size while keeping the proportions, you can hold Shift while clicking and dragging. Let's also make we can change the color. We will put, let's do a slider or a fader. So I chose fader V, V for vertical, and it looks horizontal because we've chosen a horizontal layout. So when you choose horizontal, all of the orientations get switched. So let's actually pick a different one. We'll do horizontal fader. So we got one of these. Just make it nice and big. And I guess we'll also make a knob. I don't know if we're going to use all these, but maybe we will, maybe we won't. But we're just making a few widgets that we can interact with. All right. So you just drop a few widgets on the page, and the next thing we want to do is make sure to save this layout. We'll call it simple test layout. And you want to make sure that this goes into the layouts folder. When you install Touch OSC, it goes, at least on Mac, it goes into your applications folder. And so Touch OSC editor, and then in there you have the app itself for the editor, and then a folder called layouts. So you want to make sure the layouts folder should show up automatically, but just make sure you save that in layouts. All right. Next thing we ought to do is make sure that your mobile device and computer are on the same network and that they're configured to talk to each other. So the first thing you ought to do is get the local IP address of your computer running Touch OSC editor. And on Mac, you can go to System Preferences and Network. And so I'm on the university, the sort of secure university network here, Illinois Net, and my local wireless IP address is 10.193.250.5. So I'm just going to keep that away in case I need to reference that. And we're going to go into Touch OSC. And we're going to go, so we're not in any of the interface pages. We're going to come back out and click on OSC in the connection section at the top. And you want to make sure OSC is enabled. And I've already done this, but you want to set your host IP address to be the address of the computer running Touch OSC editor. And then there's some other port information. The the local IP address at the bottom is the IP address of your mobile device, so that can't be changed. But you do want to make sure that both devices are on the same network. And then the port information here is well, to take a few steps back. In the world of OSC, a network device is defined by two things: an IP address and a port on which the device is sending or listening for messages. So SuperCollider, we're getting ahead of ourselves a little bit here, but the SuperCollider is two programs. It's the language and the server, or sclang and scSynth. And by default, sclang listens for OSC messages on port 57120, which is why I have that set here. And the server listens on 57110. So just these are just default values. They can be changed in SuperCollider. They can be changed here. It's really just an arbitrary number that represents you can kind of think of it like a channel, right? So we're only sending OSC messages on this port, and you just got to make sure that the ports are talking to each other. But the most important thing right now is just make sure that you got the host IP address there. All right, and so then in TouchOSC, we've saved it in our layouts folder. Now we're going to click this green arrow sync button. And we click sync, and a little window with some instructions pops up. So the first thing is make sure your device is connected to the same network as this computer, and we have done that. They're both on the same network. Then we're going to go to TouchOSC on the mobile device and navigate to Layout, Add, and then select this machine's name from the list to download the layout. So we want to keep this window open because this is sort of actively sort of broadcasting the new list of layouts that we have. So we are going to go to TouchOSC. We're going to go to Layout. And then at the top, we're going to go to Add. And I've found that this happens sometimes where in some cases you might see your device pop up in found hosts or editor hosts. I think editor hosts is where it shows up. But if it doesn't, you can enter it manually if you know the IP address. So in the upper right corner, we're going to click on Edit. And then in the upper left corner, we're going to click on the plus to add a host IP address. And so now I'm just going to put in my local IP address. And I'm going to double check, because this is an easy way to mess things up, is just have the wrong IP address, and just you'll be wondering for many minutes why it's not working. So that looks good. We're going to say done. And now editor hosts appears here, so we're going to click on it. And now we should see simple test layout. Yeah, here it is. Right here. So we're going to click on that. And then we're going to click done in the upper right. And there is our simple test layout. So we can interact with it. And it's all working. It's multi-touch, which is sort of the nice thing about it. Okay. Now I am going to oh yeah, and also you'll notice in the upper right, maybe you can just sort of see this, there's a little green, there should be a little green LED that's coming on. It's like right here. When that green LED lights up, it means OSC data is being transmitted from TouchOSC and being sort of sent out to its its host IP and port. And it's also possible to send OSC to TouchOSC, which we'll do shortly. And when it's receiving OSC, you'll see a little red LED pop up. So it's just like a little confirmation that everything is working. All right, we're gonna tuck this away. We're gonna float it on top and make it kind of small. So, and all right, so we can stop sync, and we'll keep TouchOSC open. There's one more thing I want to point out, which is the OSC section right here. So if we click on the panel, we can see we have a /1 in the OSC section. And if we click on one of these units, the address here sort of changes. We've got /1/toggle1, This fader is /1/fader2 /1/rotary1. And this string of characters here represents the OSC address, or the address pattern, or it's got a couple of different names. Let's see if I can. I'm just gonna look on the on this here. So the I think if we go back. Yeah, OSC address patterns. An OSC address pattern is an OSC string beginning with the character /. And you can think of this as being equivalent to the message type in the MIDI protocol, like whether it's a note on message or a note off message or a pitch bend message or something, right? The only difference is here we're not limited to you know, those predetermined categories. In fact, we can uncheck this auto box and make our own OSC address for each of these items. So we'll call this one a button. And I think we'd actually have to, maybe we won't do this, but I think because we'd have to resync and update the layouts. So maybe we'll just leave this as is. I think it's not going to go back to its default, and we'll just do it this way. Toggle 1, I think it was. Or we'll just check this auto box again. So we're fine. We can deal with these OSC addresses. We just want to keep in mind these addresses because we're going to need to know these in order to receive OSC data. Yeah, so hopefully you guys can work out how to find local IP for Windows. I do not know off the top of my head, unfortunately. I know you can go into like your can you go into your command line and type ifconfig, I think, or ipconfig. It's one of those two. I think ifconfig will just dump a bunch of data about your network connections. No, it sounds like you guys got it figured out. Okay. Anyway, so we'll keep TouchOSC. I'm just going to hide that temporarily, and let's get into SuperCollider here. So we've got our interface on TouchOSC. And we're going to send OSC to sclang. And so the first thing we can do is, if you remember from our MIDI lecture, we could do MIDI func.trace true, and this will just sort of it's like kind of debug mode where it just posts every MIDI message that comes in. We can do something very similar. We say OSC func.trace true, and I'm just going to run this, and already a bunch of stuff starts coming in, and I'm not sure I know how to suppress these if we're tracing every OSC message, but you can sort of see, well, I'll make this false for a second, just so they stop coming in. And so we'll take a look at this here. OSC message received, it's got a high precision timestamp. This 127.001 means it's coming from, so I see. So this is coming from SC Synth because I've got the server booted. So I think if I quit the server and then trace OSC messages again, those should not be coming in anymore. Right? So I can see it's coming from my own computer and it's coming from the port that SC Synth uses. And it's being sent from 57110 to 57120. So it's just sending a message with the address status.reply and then just a bunch of information. Like this one is obviously the sampling rate. And this is maybe like the actual sampling rate. I don't know. Okay, but that's kind of distracting. So we're gonna trace this. We're gonna turn trace true again, and now we're gonna go over to my interface here, and I'm just gonna push this button here. So we got an OSC message. Timestamp. It came from a different network device. I think this is this is the wireless, the local Wi-Fi address for my iPad, and TouchOSC is sending on port. It's listening on port 9000, and it's sending to 57120, which is where the language is listening. And then we got our actual message, which begins. It's an array, and it starts with the address /1/toggle1, which is exactly what we expected to get from this toggle, right? /1/toggle1, and then whatever numerical data is associated with that button. And it happens to be a single floating point number, which is 1. We'll press it again, and we didn't get anything. Weird. I guess it dropped that message. I am using you know, a pretty heavily trafficked network, so I don't think it's out of the question to expect a couple of dropped messages. But you can, you know, if you use a sort of a private little wireless router of your own and make your own little network, then it's much more consistent. But anyway, I'm just pressing this button here. We get 1, we get 0, and on or off. And we can bring this fader up, and we can bring this fader down. So it's really much more precise than MIDI. MIDI would be stuck with just 128 integers here, but we've got some really high precision here. Very nice. So that's our fader, and then you can see it's coming in on a different address. And then let's turn our knob. That's coming in on /1/rotary1. So hopefully you've is everyone sort of following along? I hope I've been going at a reasonable pace. Let me know if be good to know if you've got a little Touch OSC custom interface up, and if you're getting data into SuperCollider at this point. Right, so we can see we've got that data. Not getting any messages in SC. So obviously you want to check that your devices are on the same network and that the it's sending to the correct, you know, you got the right host. What do you call it? Oh, sorry, I'm in the wrong thing. The right host IP. And that you've got your outgoing port 57120. It could also be like when the first time I try to have these two devices talk, I get a little pop-up that says, do you want to allow network communication? So it might be a security thing, just if you're on Illinois Net. But other than that, in some cases, like just quitting SuperCollider and opening it up again, or quitting Touch OSC and opening it up again, sometimes will fix the problem. Cool, Justin, that's good. I'm glad you're getting messages. Missed the 57120. That would do it. Okay, great. Let's get back to our interface. And we are going to be a little bit more precise now with receiving OSC messages. So whereas with MIDI, we made a MIDI-def.noteOn or .cc or whatever, we're going to do OSC-def.new. There's no .cc, there's no note-on. It's just an OSC receiver. So very similar syntax. We can call this whatever we want. This first symbol, it's just a way to refer to this particular OSC def. This is not the same as the address string. We're going to get to that shortly. And then a function to be evaluated whenever the OSC def is, whenever a message is received. So I'm going to go to the help file for OSC def. We're going to go down to oscdef.new. And so we've provided our symbolic key, and now we have a function which will respond to the incoming message. When evaluated, it will be passed the following arguments: message, time, address, port. So let's make those. And again, you can name these whatever you want, but it will expect this. This is going to be treated as the message, the time received, the address of the IP address of the receiving device, and then the port on which it was received. And for starters, we're just going to post all of this. Now we're going to close our function, and then another thing we need is the path. So this is the address, like URL address style pattern that starts every OSC message. So we're just going to listen to the button for now. And I think for this you can do single or double quotes. I think they both work, but you want to do /1/toggle1. You know, just copy the address exactly. And I think that's all we need. We're going to rely on, we could also say nil for source ID and then 57120 for the port we're listening on, but 57120 is also the default port that sclang listens to, so I think these are not strictly necessary. Okay, so this means now whenever we touch this button, we should see all of the OSC data posted in the post window. And we do. There it is. Right. Oh, and I guess we're still tracing, so let's make that false. Right. So every time we touch the button, we get an array containing the message, which is itself an array, timestamp, an instance of a class called netAddress, which is SuperCollider's way of creating instances of objects that represent network devices. So it's got an IP address and a port, and then the port that it's listening to, or the port that the message was received on. So that's the essence of OSC defs. If we wanted to be not quite so verbose, we wouldn't post the whole thing. We can just say message.postln. And the nice thing about OSC defs is that they're live coding friendly, which means we can just keep the symbol the same and overwrite it, and it's it sort of eliminates the old one and overwrites it with this new one. So now we only get the message array, which is the address and the value. And we could go even further and just say message at one.postln, and this is now we're just seeing the button value. All right. Now we can, I'm going to copy this and modify this so that we have a similar object for the fader and the knob. So the address, we should give these different names. We'll call this get toggle. Call this get fader and get knob. And I guess we'll also, we still have this get OSC def floating around, so we'll free that. So now we shouldn't see anything, right? So we press the button, we get nothing. So we will say, all we need to do now is just change the addresses. So we have fader 1. I think it was fader 2, wasn't it? Let's double check. That was /1/fader 2, and this is /1/rotary 1. So we'll run these 3, and now we should just see the button value, and we've got our other OSC def for the fader, so that's coming in, looking good. And then our knob also going from 1 to 0. Great. Before we get into doing some sound, I want to show you the way of, right now we're, in SuperCollider, we are receiving OSC messages, but we can also go the other way. And the first thing we need to do, so basically we can use SuperCollider to update the state of Touch OSC. There are some cases where you have 2 devices and they're sort of talking back and forth to each other with OSC, maybe sending messages to and from. In some cases, it's just a one-way street, but it can be either way. So we'll make a new object called Touch OSC, and it's going to be a new instance of a net address. And a net address, let's bring up the help file. This is a very common class to be using if you're doing anything network related, where you're sort of talking to other computers over a network. And so netaddress.new needs 2 things. It needs an IP address, which needs to be provided as a string, and then a port number, which is just a regular integer. So I'm just gonna get my host, my sort of local IP address of my iPad here. So that is 10.194.216.212, and it needs to be a string, because this is going to be nonsense, because you can't have an integer with multiple decimal points. And then so Touch OSC is listening on 9,000. All right, so we can say done here. Go back to our layout, and we're going to create this object. So now in SuperCollider, we have an instance of an object that represents the iPad, which is our network device. So now we can say TouchOSC.send MSG message, and let's see if we can maybe bring back the help file here. So send message, right? It's the first instance method, and we do the we send it the message consists as it was previously, the same situation, an OSC pattern style address, so / whatever, and then whatever data is appropriate for whatever you're sending to. So we can say, and And again, I think single or double quotes work. You see a lot of single quotes in the help files, so you know, I will do it this way, single quotes. So we want to say /1/toggle1. So that's the address. That determines sort of what objects are going to be listening for that message. And then we'll say 1. I don't know if we need to do 1.0. I think 1 would be fine. So when I run this line, we should see the toggle button come on. And we do. Excellent. And we can send it a 0, and off it goes. And yeah, when we do this, it's like a passive thing. So we're not doing a sort of feedback thing. You can make it, I think, so that when you send a 1, it also has the effect of you pressing this. I'm not sure. But it's just we can also say let's set the fader 2 to be a value of 0.5, and so there we go, 0.75. So OSC goes both ways. So this is sending OSC from SuperCollider to TouchOSC, and receiving OSC in SuperCollider from TouchOSC. Great. So now let's do some sound. So we need to boot the server, and I'm going to make a quick synth def. It's going to be very simple, just to, you know, we'll call this ping, little ping sound. Freak 500 out 0, and I'll say var sig env. Freak, we'll make it stereo. Let's make it quieter, because yeah, and then times env out.ar out sig. Very boring synth def, but we'll deal with that. Okay, so I'm hearing that. I think you should be hearing that too. Let's turn this up just a little bit. Okay, frequency is working. All right. Hey, you know what? Let's do a pan argument too. I feel like panning today, so we'll make this not stereo, and we're gonna say, yeah. So our SignOSC is no longer stereo, and instead we're gonna be saying, pan it using pan 2. All right. So now we can say pan -1, +1, and 0. Great. So now we have some spatial control as well. All right. So now I'm going to make let's see, and let's make an OSC def, and we'll call this make ping, and we'll say arg message. I'm omitting all of all this stuff because I don't think we're going to be using time, address, port. We just really need the message. And we'll say if message equals 1. Nope, sorry. If message at 1, right? We don't want the whole message is going to be an array containing an address string followed by the value. So we just want the value itself. If it's 1, then post ln. Right? We're not going to make sound just yet. I just want to make sure this is working. And this is going to be coming from /1/toggle1. So basically, when the button's on, we'll see the message. And let's OSC def.free all. Just get rid of our whatever, all the stuff up here. We can just say, all right, get out of here. So, all right, so now, so we see it. And if I press it off, we shouldn't see anything. So we're only getting the on messages. So we're successfully filtering out the messages based on the content. So now instead of post lning, we will say synth. I'm just going to copy this here. So if the message is 1, then we make a ping, and let's say xbrand 300 2000. And well, let's pan randomly as well. rrand minus 0.5, positive 0.5. And I'm going to space this out so it's a little bit nicer to read. Yeah, so that's working. You know, for a finite duration, just one-shot envelope, it doesn't really make a ton of sense to have a two-state button, because you know what would make more sense is to do a push button, you know, a toggle button. So we'd probably go into Touch OSC and make ourselves a push button, and you know, we could change its address to be /1/toggle1, or probably we'd just redefine our SuperCollider code, but we'd get rid of this one, add this one, and then just link up these two interfaces, making sure they're expecting the correct OSC messages, and you know, so we're working with what we got here. I didn't really think ahead too much, but you can see the gist of it. It's pretty easy. You know, but this would make more sense for like a gated envelope. So we set the gate on, and the sound is sort of held down, and we could have another OSC def that adjusts the frequency or the volume or something using this, and then we can turn it off like this. Right. So that is that's the basics of getting OSC. So you know, and let me show you something else here. This OSC message can come from anywhere. It doesn't have to be the iPad, as long as it's a message that you know, that as long as it has this address, so that this OSC def is listening to, and you know, if it's got the right data, if its first indexed item is 1, then we'll make a synth. So in fact, I'm gonna do that. I'm gonna say me. I am a net address, and I could do 127.0.0.1 to use my loopback self-identifying address, but instead I'm going to put my actual local IP in here, which is, I've already forgotten it. Where's my system preferences? Is it 10? 193.250.5. And I'm listening on port 57120. Okay, so we're going to run this. That's me. And now I can say me, send message, /1, /toggle1, and the value 1. So this, I believe, should also, you know, this OSC def should see this as indistinguishable from me pushing the button on the Touch OSC interface. So let's try it. It works. Awesome. And I can just, you know, it doesn't have to be 0. It's just whenever, you know, so the address has to match, and this has to be true in order for the conditional function to be evaluated. Right? So let's do something a little bit different. Let's free all, and I'm going to redefine this a little bit, copying and pasting it down here. We're going to sort of forget about our interface for now, and we're just going to do some you know, computer to computer stuff. You know, it doesn't really matter that it's the same computer doing both things. So we'll say make ping, and what I'm gonna actually change my synth def a little bit. I'm gonna make it a little bit more robust, and so I can't, you know, mess it up too bad. We're gonna say freak equals freak.clip. Keep that within sensible boundaries, and we're also going to say pan equals pan.clip -1 1. So that way, even if I give a bad value for frequency or a weird value for pan, they're going to get clipped to the appropriate ranges. So we'll do that, and we're going to say arg message, and what we're going to be expecting, message at 1 is going to be frequency, and message at 2 is going to be pan. So we'll say synth.new ping freak is message at 1, and pan is message at 2. And I think that ought to be fine. We've already, nope, sorry. We just need to do that. And let's just make a different address here, make ping, right? So just slash make ping, right? So now I can send a message to myself that is, it's got the address make ping, and then I'm gonna say, give me a frequency of 400 and a pan position of -0.5. And let's just double check I've done all these. So we should hear a 400 hertz ping that's panned sort of to the left. And I think that worked. To the right. And make the frequency higher. Yeah. All right. Everybody following along? Well enough? Make sense? You know, there's something else we might even be able to do to make this even more robust, which is like, well, for example, let's see what happens if I send the string yo. Yeah. Okay, so that's actually pretty harmless. It's just using the default at that point. But we might want to do something like if two things need to be true, message at 1 dot is number, because we can say stuff like 5 dot is number. That's true, but the string 5 is not a number. So this is just like, again, sort of sterilizing the message. We want to say that's got to be true, and message at 2 is number. They both have to be numbers. And if that is true, then we can go ahead and make a synth and plug those values in. Right, so we get our message, and we're just putting a comment here to ourselves, and then we're going to say, okay, if these are both numbers, then we can go ahead and make a synth. But if they're not, don't do anything. So now this shouldn't make any sound. But if we say 2000, there we go. Exparand 300 2000. We can even make a routine here. Sort of r equals routine.new loop. Do this, wait for 1/4 of a second, and play it. I gotta put these in parentheses, of course, if I want to be able to run that clump. So we're just my computer. I'm from sclang. I'm piping out a sequence of OSC messages, and I'm sending it to me, which is a net address that represents my computer, my local address, and the port that sclang is listening to. So I'm kind of sending messages to myself. So here's where I'm hoping this lecture will get kind of exciting. So I'm hoping there are at least some of my students out there who are on Illinois Net right now. So if that is the case, then you should be able to make a net address instance, and it would you would not use your own local IP address, but instead you would put this IP address, which represents my computer and the port that my instance of sclang is listening to. So you can call this, you know, Eli or whatever, and then you should be able to send me this message. And in fact, you could even add an extra, you know, your name, you know, or your username or whatever you want to put there. Just tack on an extra thing, and then that way, when and I'll also post the message here. So now, if I send this, I get you know, we get a sound because I'm getting a make ping message, and it's got valid data for the message at 1 and message at 2, and then also we're just adding on an extra piece of information and posting it. So I wonder if this is going to work. is anyone actually on Illinois Net and willing to try this? Do like a little networked haphazard improvisation here. That would be really awesome. If not, we'll do it in class on Thursday. Otherwise, it's just going to be me talking to myself out here on the internet. Oh, there's one. Awesome. I'm so pleased. That worked. Oh, here it comes. There's 3 in a row. Nice. So yeah, you could also even do something like this and just kind of spam my sclang with a bunch of messages. I bet you could actually crash the stream right now. Yeah. Yeah. All right, nice. B. Hanks. Crossing the finish line first. All right, well, I'll stick around if anyone else wants to send me a few tones. Nice, there it is. Yeah, there's a lot of different paths you can pursue here. I could have a bunch of different synth defs, and then we could even incorporate the name of the synth def into the into the OSC message. So the first argument after the address could be which synth def you want to play, and then you can plug in a bunch of values here. Yeah, and there is also a way. It's like sort of a different approach. Instead of sending OSC to an sclang, because what's happening here is we're kind of doing a little message relay thing here. So, for example, B. Hinks is sending me an OSC message. My instance of sclang is receiving it, and then as a result, my instance of sclang is making a new synth, which is in effect sending an OSC message from my instance of sclang to my instance of sc synth. In fact, let me just demonstrate that for a second. You can keep sending me tones if anyone wants, but let's see. So we know S is the localhost server, but the server represents a network device. So we can say s.addr to get the net address that represents the server. So it's just going to give me my loopback IP address here, and 57110. It is possible. I've done this 2 years ago, and I tried it again. I wasn't as successful. I wonder if there's something that's been changed. Oh, DS, send in the pings. Awesome. I wonder if something has changed in a newer version of SuperCollider. I'll have to do a little bit of research, but I do know that when you say synth.new, this is a sort of convenience, more human readable tool for the user, so you don't have to explicitly send an OSC message to the server. But it is possible to, when we say synth default, say x equals synth default, we can make an instance of the default synth def. Let's free that, and I think we can say amp 0.8. So we just have this default synth def. But we can say s.send message, and then in the help file called server command reference, it gives you a list of all of the OSC message addresses that the server expects. And so they all start with a slash. So there is one that is s_new, I think. s_new. Yeah, so this is the address corresponding to a message that the server will respond to by creating a new synth. So let's send it that message, s_new. And the first thing it needs is the name of the synth def, synth ID. This is normally generated for us, but we have to do it manually in this case. Let's pick a random number. An add action, so 0, 1, 2, 3, 4 represent add to head, add to tail, add before, add after, and add replace. So, we'll say, it doesn't really matter. We'll say add to head. And then target ID, and the node ID of the default group is 1. So when we do this, and we send this OSC message very explicitly to the server, we create a new default synth. It's got node ID 1234, and then we can say s.send message. The message is node, so n underscore free, and then we just need to provide the node ID, and this will free the node with node ID 1234. So this is obviously not very user friendly, but this is what's going on under the hood whenever we say synth.new. What actually happens is we're sending an OSC message from sclang to scSynth, and there is a way to make the server verbose, or basically have it kind of do the OSC func.trace true, but for the server, so it just sort of posts every OSC message that comes through. I don't remember how to do that off the top of my head, but it is possible to basically create an instance of a server, say something like server.new or server.remote, and make an instance of a server that represents scSynth running on somebody else's computer, like my computer. And then you can actually, instead of adding a synthef, you can send it to a remote server, basically stream the synthef over the network, and then you can play that synthef. So you basically, instead of talking to sclang, you're talking directly to scSynth on another computer. I've usually found language-to-language communication is a little bit easier, just making an OSC def and then making a net address object that represents that person's instance of sclang listening on 57120. Yeah, so that's basically it. Let me know if anyone has any questions or anything, but I think this is a really fascinating topic. I think OSC is a really, really handy protocol for communications. Very open, very flexible, network friendly. But this will be the focus of the in-class problems on Thursday. And the take-home, I'll basically ask you to make your own TouchOSC interface. And in addition to submitting your SuperCollider code, you'll also submit your layout, wherever it is, layouts. Right, so, you'll basically take this simple test layout and you'll, compress this together with your SuperCollider code. Just submit both files. All right, well, so I guess that's going to be it for this week. OSC is pretty handy, pretty deep. Nice. I'm glad I stuck around for that. I love it. Cool. So we're gonna do kind of like an in-class improv jam network OSC thing on Thursday. Maybe I'll ask you to sort of partner up with somebody and send messages back and forth. Yeah, it'll be fun. So that's OSC in a nutshell. So thanks for watching this week. And next week, I think 2 years ago when I taught this class, the week after this was using the pen class and doing animation. So where's my yeah. How cool is it that you can just hop onto Twitch and pipe some OSC into your into SuperCollider and sound comes out of the stream? Yeah, so pen is a class that allows you to draw on GUI views. So you can make all sorts of shapes and circles and rectangles and lines and stuff, and you can even there's another class called user view, which is a special kind of blank view that's optimized for interacting with pen. And so there's also an animate method, so you can basically set a sort of animation sequence and then set animate to be true or false to basically bring it to life. SuperCollider is not program that I would describe as optimized for video rendering. But you can do basic stuff, and it's kind of fun to play around with. But if you're actually doing interactive video stuff, you should probably use a dedicated piece of software like processing or, I don't know, VDMX or Isadora, all of which are actually OSC compliant as well. There's more and more OSC compliant software out there. There's like, I'm pretty sure Ableton does OSC. I mean, Max MSP does OSC. C-Sound does OSC. Yeah, it's kind of it's become a pretty standardized way of getting computers to talk to each other. All right, so that's enough out of me. Everyone taking 499C. I'll see you on Thursday for some in-class goodness, and we'll be back same time next week, probably. Thank you for watching. You guys are great. Right, so we'll probably do some pen and animation next week. If anyone has any other topics that they want to see before the semester's over, I'd be happy to entertain those ideas. I'll try to accommodate as best I can. All right, so thanks again for watching, and see you all on Thursday and or next week on Twitch.